Hello and welcome to Cloud Tech 10 for the 11th of December 2017. I'm Mark and I'm going to tell you all the latest news about Microsoft Azure from the past week in 10 minutes or less. The Kubecon 2017 event in Austin, Texas last week saw the announcement of several new tools for working with Kubernetes and Azure resources. You can manage serverless containers using Kubernetes with the Virtual Kubelet. When Azure Container Instances was announced earlier last year, an experimental connector was made available that made it possible to spin up containers on demand, orchestrated by Kubernetes and taking advantage of Azure's per-second billing whilst removing the need to manage virtual machine infrastructure. A new version of this connector is now available as the Virtual Kubelet. It's open source and as of now supports standalone containers deployed through Azure Container Instances or hyper.sh. And as it's an open source project, contributions to support additional standalone container services are invited. Using the Virtual Kubelet with Azure Container Instances and the Azure Container Service is straightforward. Whilst connected to an existing Azure Container Service deployment, you can deploy the Virtual Kubelet using Helm. The release name is set to Virtual Kubelet. Then we set chart URL to the location of a Helm chart in the Virtual Kubelet GitHub repo. Next we run Helm install, passing in the two environment variables we just set, and we configure the client ID, client key, and tenant ID for a service principal that the kubelet will use. It also needs to know our subscription ID, the resource group where the Azure Container Instances will be created, and Azure region. This is the name for the node, and we specify that it's Linux. Helm gives us the command line we can use to check the deployment status of the Virtual Kubelet. Once that shows us running, I can now run kubectl get nodes, and I can see that I have an additional node in my Kubernetes cluster. Now when I configure a deployment to target the Virtual Kubelet, it will automatically create Azure Container Instances in the background and deploy it and run containers from there. The Open Service Broker for Azure provisions managed services in the Azure public cloud. It's compatible with the Open Service Broker API and works with Cloud Foundry and Kubernetes. You can automatically deploy services such as databases, event hubs, Key Vault, or storage. To use this, you'll first need to add the service catalog to your Kubernetes deployment. This can be done using Helm. We add the repository and then install the service catalog. Using the kubectl command, we can see that we now have a service catalog. We need to add the Azure repository to Helm so that we can install the remaining components. Next, we need a service principal that will be used to manage resources in our Azure subscription. I'll use the azad create for RBAC command to quickly create one. The output from this command should be saved for later use. Next, I'll populate some variables to hold some of the values from our freshly created service principal. So we'll create variables to hold the client ID, the client secret, the tenant ID, and we'll also need our Azure subscription ID. Now we use Helm to install the Open Service Broker for Azure. We need to pass in the environment variables that we just set. After a few moments, the broker is ready to use. It's possible to get a list of the resources that we can deploy using the broker with the kubectl command, but these commands are a little complex and the output isn't very friendly. To help with that, a service catalog command line tool has been made available. For this initial release, you'll need to download the tool using curl or something similar and then make the downloadable file executable. Once that's done, running svcat get brokers will show a list of available brokers, and we can see that the Open Service Broker for Azure is ready. svcat get classes shows a list of available services, or we can run svcat get plans to see the specific plans available for each service. As an example, a WordPress Helm chart is available which will deploy a WordPress instance into Kubernetes, but it will use a managed Azure database for MySQL as the persistent data store. We use Helm install to kick off the deployment. It will take a few minutes for everything to be created, and when it's done, you'll see the externally facing IP address published. Let's go to that IP address in a web browser, and there we see our WordPress deployment is up and running. Let's jump across to the Azure portal, and in there we can see an Azure database for MySQL instance has been created. And if we look at the Kubernetes UI, we can see the details for our deployment, including a set of secrets, which includes the details we need to connect to our MySQL database running in Azure. Pivotal Cloud Foundry will shortly be coming to Azure Stack. This means you can now deploy applications written using any language, including Java and Spring, to public, private, or hybrid cloud environments securely and easily using Cloud Foundry. Also, a new smaller footprint Pivotal Cloud Foundry image has been added to the Azure Marketplace. The small footprint runtime image is similar to the traditional image, but uses 70% fewer virtual machines, making it ideal for proof of concepts, edge locations, or other use cases that require minimal infrastructure. And if you use Visual Studio Code, you can now use the Spring Boot development extension pack for developing and deploying Spring Boot applications. cloud-init is a popular method for customizing the configuration of a new Linux server on first boot. It's used to install packages, write files, configure users and security, and more. Preview support for using cloud-init with the Red Hat and CentOS images in the Azure Marketplace has been added. To use cloud-init, I provide a configuration file. In this simple example, I'm just going to make sure that all packages are updated to their latest versions, and I'm going to install the HTTPD package. Using the Azure CLI, I run the azvm create command as usual, specifying the resource group where the virtual machine will be created, the machine name, the image I want to use, and then the custom data option points to my cloud-init configuration file. Now the virtual machine will be deployed, and once the deployment has completed, the cloud-init process will start and perform the operations I've requested. If I connect to the server, you'll first see a message indicating that this server has been built using the cloud-init preview image. If I take a look at my server's log files, in here I can see that the package manager was started to update my installed packages and to install the HTTPD package. If I use the package manager to install updates, you can see that it's already up to date. And if I install the HTTPD package, you can see that's already installed as well. The Developer's Guide to Microsoft Azure is a new ebook that can be downloaded for free. It's targeted at developers considering using cloud technology or those who are already working with it. Starting with an introduction to cloud computing, the book covers the features and services offered by Azure, including virtual machines, containers, Azure Functions, Logic Apps and App Service, CDNs, Redis Cache, Traffic Manager, and Azure's storage options, including disk, file, queue, table and blob, as well as Cosmos DB, Azure SQL Server, MySQL or PostgreSQL. There are chapters on using Azure's intelligence and cognitive services and security. There's also a walkthrough of the Azure portal and a step-by-step guide to developing a Node.js application with MongoDB. As well as the Developer's Guide to Microsoft Azure, a new Azure Application Architecture Guide has been made available. Once you have a grasp of Azure's offerings, this guide can help you understand which technologies to use and how to use them effectively. It covers different architectural styles such as N-tier applications, WebQueue Worker, and microservices, technology choices to help you choose between options such as IaaS, PaaS, functions or containers, design principles to make the most of building and running applications in the cloud, the pillars of software quality which covers scalability, availability, resiliency, management and security, and cloud design patterns. The guide is available online at this URL. You can also download a PDF version of the guide for offline reading. L-series virtual machines provide a storage-optimized configuration for demanding workloads such as MongoDB, Cassandra, or Cloudera. The LV2 series of virtual machines has been announced in preview. These new servers use AMD EPYC 7551 processors with sizes available supporting up to 64 vCPUs, 512GB of memory, and 8 1.9TB SSD-based local storage. As well as the preview of the L series, the B and M series of virtual machines are now generally available. The B series is a burstable virtual machine. It provides a low-cost option with the option to burst when additional capacity is needed, making these virtual machines ideal for workloads like websites, small databases, or development and test environments. Meanwhile, the M series provides the largest VM sizes available in Azure, with options offering up to 128 virtual CPUs, 3.8TB of memory, and 4TB of local storage, with support for up to 64 data disks. Version 1.4 of the Azure Management Libraries for Java has been released. This is an object-oriented API for managing Azure resources from Java. In this release, support has been added for the Azure AKS Managed Kubernetes service, deploying from container registry to a Kubernetes cluster, applying locks to virtual machine resources, and express route circuit peering.